Kids, I hope that you are doing well today. This is Mr. Trice coming to you. Just wanted to let you know that we greatly miss seeing you guys, but we hope that you are getting some good quality time with your family. Today's focus in math will be with perimeter and some division problems. The perimeter problems that we are doing will look a little bit different from some of the things that you guys have done in the past. Now, through the video, if there are times that you need to stop the video to catch up, go ahead and do that. You can always rewind the video. There will also be times that I ask you to go ahead and stop the video so that you can work out some problems yourself or get materials. So this is one of those times. For the lesson, you will probably want to have in front of you the student book, which is your yellow book, with page 227 and 228 open. You'll also want a pencil and some scrap paper so that you can work out some problems with me. So go ahead and stop your recording right now, and then you can come back. All right. Our learning goal today will be I can apply the perimeter formula for a rectangle to solve a problem. Some of today's vocabulary are area, dimension, dividend, divisor, length, perimeter, quotient, and rectangle. These are not new vocabulary words to you. You have seen all of these words and have gotten familiar with these words from previous units. So nothing new on that part for you today. What is new may be the way that we go about finding perimeter. Now, normally our perimeter formula is 2L plus 2W. And I will try to write that on our screen right now. Perimeter equals 2L plus 2W. That means twice the length plus twice the width. And that's wonderful if we just have our dimensions. But in our problem today, we only have one dimension and they give us the area. So that means we're going to have to do a little bit of division. So problem number 1 says a certain rectangle has an area of 693 square meters. The rectangle is 7 meters wide. How long is it? So first of all, we have to find out what that missing dimension is and then go back and use this perimeter formula to figure out how long the total rectangle is. So let's go to our screen to work out this problem. We are going to use a ratio table strategy to help us with this type of division problem. So essentially, we are looking at 693 divided by 7. Now, I know that some of you guys may have learned long division, and that's great. We will learn a little bit of long division down the road. It does work. It's a bit tricky. It's a long process. As long as you're organized, it does work, though. But that's not our focus today. We are going to look at the ratio table to help us. I just want you guys to draw a visual, though, to help you understand exactly what we're doing on this problem. We have one dimension that's 7, and the area is 693. And I apologize to you. My stylus sometimes is skipping across the screen. Hopefully, we can get that taken care of. The problem said that these are in meters. So that's what we will go with, 7 meters. On using a ratio table, what we'll do is say that this is a rule of 7. Rule is times 7. And we are trying to get to 693. My class, my kids know to always start with something simple. So if the rule is times 7, we are going to look at, well, 1 times 7 is 7. Then we want to look at another easy jump. A lot of times my kids will say, why don't we do 10? 10 is an easy jump. 10 times 7 equals 70. Now we need to go all the way up to 693. So I'm thinking we might want to make a big jump on this. So instead of just jumping by tens or doubling, why don't we jump by 100? What if we put 100 over here? Then we're looking at 100 times 7. And 100 times 7 is 700. You can say, but Mr. Trice, we've gone a little too far. And we have, because 700 is more than 693. But if you take your 1 times 7 up here, throw it back here, we now have a simple little subtraction problem. 700 minus 7 is 693. 100 minus 1 is 99. And voila, 99 becomes our answer. So 693 divided by 7 is 99. We got there by making some logical jumps. Obviously, the ratio table worked in this situation. It's not the only strategy to solve this type of problem, but it's just the strategy that we're focused on today. We are not done with our problem yet. I am going to show you why. Essentially, we have yet to find the other dimensions. We have 7 on this side. We have 99 for a dimension here. If this side is 7 of a rectangle, that means that this side is also 7. If this side is 99, that means that this side is 99. If we use our perimeter equation, we would have 99 times 2 plus 7 times 2. In essence, our perimeter for this problem comes out to a total of 212 meters. So if we go back to this problem here, that a certain rectangle has an area of 693 square meters. This rectangle is 7 meters wide. How long is it? Essentially, it's asking, what are all of these sides added together? Or if you don't want to go through the addition, you can use our simple formula right here. All right. Let's see if you can solve for this problem right here. A paved bike trail has an area of 7,147 square feet. If the trail is 7 feet wide, how long is the trail? You can go ahead and stop right now and try to use the same strategy that I used last time to see if you can come up with the answer. For those of you that have taken the time to try to solve it yourself, I'm going to go through quickly right now to show you how I would solve this problem using a ratio table. We have 7,147 divided by 7. I'm just going to draw a visual to help us. One side is 7. The area is 7,147. On my ratio table, I have a rule of times 7. I'm going to start out a little bit easy and say 1 times 7 is 7. That's just to get my brain thinking. I'm going to think about maybe a 10 times 7 is 70. Oops, I forgot to put in what we are working towards. We are working towards a 7,147. If I go by tens, it's going to take a long time. So I'm thinking about making a huge jump. How about 1,000? 1,000 times 7 is 7,000. That gets me a lot closer to my total, my goal. I'm looking back up here. If I double the 10, that means that I can double the 70. If I double the 10, I get 20. If I double the 70, I get 140. Now I'm getting really close. If I add these two numbers here, I would be at 7,140. That means essentially I just need that one more 7 there. If I were to add this up, I get 7,000 plus 140 plus 7 gives me 7,147. If I add up the 1,000 plus the 20 plus the 1 gives me a total of 1,021. So essentially, this dimension over here is 1,021. If I put that into my perimeter formula, that means that P equals 2 times 7 plus 2 times 1,021. And if I were to solve that, I get a total of 2,056. And I'm going to go back to my problem right now to find out what the units are. It looks like feet. So we have the total length of this bike trail is 2,056 feet. And there you have it. That's how you would solve those two problems. If you need to take a break for a moment, go ahead and pause the video. In your yellow book, you'll see on page 227 some problems like this. It says to use your 60-inch length of string. Well, obviously you don't have the string in hand, but that's fine because you don't actually have to physically have string to solve this type of problem. If you look at problem number 1, it says, if you use your string to form a rectangle with one dimension of 24 inches, what is the length of the other dimension? This is what I'm going to tell you. The total length of the rectangle that you are going to draw is 60 inches. So keep that in mind. The total length is 60 inches. We know one side is 24 inches. So what I'm going to ask you to do is, instead of worrying about the string, just go ahead and draw yourself a visual. One side is 24 inches. We need to get it to a total of 60 inches. Well, if one side of a rectangle is 24 inches, the other side is 24 inches. And what we do from here is just look at doubling these two amounts. So 24 times 2 equals 48. It's getting us very close to that 60 inches. What we need to do from here is take that 60-inch total, subtract our 48 that we know that we already have, we get 12. That means that this side right here and this side right here are a total of 12. Since there's two sides, we just want to take that 12 and divide by 2. That means that each side is 6. So the top is 6 and the bottom is 6. If we look back at the problem, it says, what is the length of the other dimension? Well, we knew about the 24. The missing dimension that we are focused on right now is 6 inches. We are just working backwards a little bit to solve this problem. Remember, we're starting out with a total of 60 inches and then just working there from what we know. There is another problem on this page that I would like you to try on your own right now. It says, use the string to form a rectangle with one dimension of 19. It's the exact same type of problem. Remember that your string, or the total length or the perimeter of the rectangle, is 60 inches. So make your visual, label one dimension as 19, and then start filling in the other parts that you know. Go ahead and pause your video right now so that you can work through that. All right, we are going to move on to one of our other pages that we have for our homework tonight. This would be page 228 in your yellow book. It says, Kaylee is training to run a marathon next summer. Help Kaylee figure out how far she is running each day. Problem number 1 says, there is a rectangular path for running in Kaylee's town. Everything's a rectangle in these problems. She's running around the path every day, or she runs around the path every day. One side of the path is 5.5 kilometers long. The other side is 3.5 kilometers long. What is the perimeter of the path? This problem is a much more straightforward type problem for you. Remember, you can use the P equals twice the length plus twice the width formula. So you can take 5.5, or you can also take 5.5, multiply that by 2, and then take 3.5 or 3.5, multiply that by 2, and add those two totals together. Something that might be a little bit more confusing to you is problem D. This is where they are talking about time. So I want you to think about your clock. It takes Kaylee about 1 5/6 hours to run around the path. How many minutes does it take Kaylee to run around the path? Well, we know that 1 hour is 60 minutes. Then it says 5/6 of 60 minutes. So essentially, you are taking that 60 minutes, dividing it by 6. I'm going to let you solve that problem. And then once you get that answer, you want to then multiply it by 5. So you want to find out what is 1/6 of an hour, and then multiply that out by 5, and that'll give you the 5/6. Once you have that, then you can put down the total minutes it takes Kaylee to run around the path. And of course, then that can take you to the challenge problem, where if she ran around the path 1.5 times, 3 days in a row, how far did she run? Obviously, there's a couple of more steps in there for you. Your homework for this lesson will be to complete the 2 pages that we talked about. I took you through some of the first problems. Obviously, I didn't want to walk you through every problem. So in your yellow book, you have page 227 and 228. And then also in your pink book, you have some similar problems on page 119 and 120. Try your best to solve these problems. I know that you won't have all of the answers. Try working with your parents if they're available, or your brothers and sisters. They can help you out. Just try your best. You can do a lot of these problems. Uh, One of the last things that you'll be doing on page 120 in your pink book is actually looking at some of the metric units. So it's kilometers, meters, decimeters, and centimeters. That's a little bit of a review from some of our previous units as well. So take your time to solve that. I hope that you guys have fun, and we will talk again in the next session. Bye.